All right, welcome back to 105. Thank you for joining me today. So, today we are going to talk about arithmetic, which sounds like something everyone should know, but the rules of arithmetic in C are kind of weird. So, we will go through that today and show how it will help you in Lab 1, maybe calculating how many free donuts someone should get. So, let's start it off. Computer is supposed to help us make things simpler. One thing we would like a computer to do is arithmetic. So before we get into arithmetic, we have some more terms to explain in C. So there is something called an expression. An expression is basically a combination of like operands and operators which results in a single value. Sounds complicated, but all that really means is something like 1 plus 2 is an expression. So my operands are 1 and 2. My operator is a plus. I'm trying to add two numbers together. Or if I want to be technical about it, the number 3 by itself is also just an expression because it results in a single value. So these two things are both expressions. So in C, there's all the operators you would expect. They might have a different symbol, but there's addition, subtraction, like a plus, a minus, and multiplication is done with a star, and division, thankfully, is done with a slash. So, in C, C also follows the order of operations you're all familiar with. BEDMAS or PEDMAS or whatever they taught you, they're all the same rules. Basically, you evaluate things in order of most important to least important, right? So you always do brackets first, then you do exponents, then you do division, multiplication at the same level, then addition, subtraction at the same level. We also work left to right, so if there's multiple additions, well, we group them, like we can only do one addition between two operands at the same time. So when we group together multiple pluses, we group them starting from the left. So if we have 1 plus 2 plus 3, we do 1 plus 2 first to get the result 3, and then add that 3 to 3 to get our final result 6. So it's really important to agree on the order, as they probably taught you when you actually learned arithmetic. So again, 1 plus 2 plus 3, it's left associative, which means if I explicitly add brackets to it, so there's no kind of like ambiguity to it, well, we compute it as 1 plus 2 first, and then take the result, which is 3, and then add that to 3. If instead I said addition was right associative, that means I would start grouping from the right side first. So I would do 2 plus 3 first, and then plus 1. Because, you know, mathematics commutes and all that stuff, both of these get the same result. In C, there's going to be some weird rules where these two things will not be equivalent. If I write 1 plus 2 times 3, well, because multiplication has a higher precedence, then C will correctly compute it as 2 times 3 first, so that gives us 6, all plus 1, so our final result for 7. So the precedence rules are all available on this c++.com external reference. If you're interested in that, I also have a reference slide so you don't have to go to that website because, well, for the most part, it will do what we want it to do. So, where it starts getting a bit weird is that division of integers behaves a bit differently than what you're used to. So, if I write out the types of the operands, so remember in C, every single name is associated with a type. If I do an int divided by an int, the result is another int value. It's not a decimal or it's not a number with a decimal in it, so it's not a double or anything like that. So, first surprising thing might be if I do 5 divided by 2, the result is 2. There's no proper rounding. The result is just the quotient. It just kind of chops off the decimal point and gives you that as the result. So, there's also a modulo operator in C, which allows you to get the remainder of a division. So it has the exact same precedence as division and multiplication. So for example, if I do 5, how we would say this is 5 mod 2, that the answer in this case is 1. So if I divide 5 by 2, the answer is 2 remainder 1. So the division will give you the quotient, the modulo will give you the remainder. So in this case, the remainder is 1. So again, to do a modulo, both of the operands must be an int, because if they're both a double, then I will just get back, the proper result as a number with a decimal in it. So C has a few rules for how the modulo operator works and how division works. The quotient is always something called truncated. So, which means the result should just chop off the decimal point. There's no proper rounding or anything like that. So, there's also a rule for C to say what the result of a division should be, or the remainder, which says that if I can represent A divided by B, then this equation should be true. So, if I do A divided by B, which gives us the quotient, and then multiply it by B, so multiply it by what I'm dividing by, and then add essentially the remainder, the result of that should be equal to A, which seems to make sense, but it behaves a bit weird with negative numbers. So if A is 5 and B is 2, if I do A divide B, well, the proper answer is 2.5, but since division C with ints is truncated, the answer is just 2. So the answer is 2, and then for this equation, so if I do 2 times b, that's 4. That means my remainder must be 1 in order for this equation to hold and make sense. So it gets a bit weird once the numbers have a negative in them. So if I do a is 5 and b is negative 2, the proper answer is like negative 2.5, right? But it gets truncated in C, so the result is negative 2. But if I try to get the remainder, in this case the remainder will be 1, because the quotient of the division times b is equal to 4, and then I have to add 1 to get back to 5. Turns out the remainder flips if a is negative 5 and b is 0, or sorry, b is 2. So in that case, a divided by b is still negative 2 because, well, it's supposed to be negative 2.5, but it gets truncated. But now this time, a mod b is equal to negative 1 because, well, negative 2 times 2 is negative 4. And in order to get back to the original answer of negative 5, the remainder has to be negative 1, which seems a bit weird. In some languages, the modulo always has to be 0 or positive. In C, it can be negative. And then finally, if a is negative 5 and b is negative 2, then a divide b is 2, but the modulo is negative 1. So gets a little bit weird with that. So for the most part, you don't have to worry about this. This is just extra information, but be alert if one of the inputs can be negative, you might have to think about this. But for the most part, as far as I'm aware, in all the labs, all the numbers are positive. So let's see that as an example. So, so here's just to show that what I did was true. So I will create a little program here that just sets a equal to 5 initially and b equal to 2. And then I'll print off for each line 4 numbers, what a is, what b is, what a divide b is, and what a mod b is. And then I will change the numbers, print it off again, change the numbers, print it off again, change the numbers, print it off again. So it should give you the exact same results that are in the slide. So I can run this as just mod. And then see that indeed the answers are the exact same things that I got on the slide. So one of the caveats there is that it says if we can represent A divide B. So why might not I be able to represent A divide B? Well, the main thing we can't represent is division by 0. So in mathematics, this is impossible, but I can actually write it in C. So in C, usually if you write 1 divided by 0 and give it to a mathematician, they will have a slight heart attack that you don't know what the hell you're doing, and you'll be able to prove that 1 equals 2 and all sorts of weird things. But C doesn't really care about mathematicians, so it will let you write something like 1 divided by 0. It will give you this nice little warning here that says division by 0 is undefined, but I'm free to ignore that. So if I just run my program, and it's called divide by 0, weird things happen. So in this case, it will say it is negative some gigantic number. And because C says something is undefined, it really means it's undefined. So in fact, if I do this and run it again, I will get a different answer every time. That's slightly-ish, kind of close to the same, but kind of not the same. So whenever C says something is undefined, alarm bells should be going off, and you should try in your whatever power you have to fix that. Because if something's undefined and it just happens to work on your machine, that's actually worse than it kind of getting a random value, because it might work on your machine, and then you give it to me, and it doesn't work on my machine, because technically my machine does something different than you, because it's technically undefined. So avoid this at all cost. So that warning, it says the value you get back is undefined. Again, could be different every time. Hopefully that is the case. It could also be the same every time, which is, I would argue, actually worse. So on your computer, it might also be different than when I run it on my computer. So you might get, a giant positive number instead of a giant negative number. Who knows? You can have fun and run it and see what happens. So with the US spelling in C, we call this undefined behavior. Undefined behavior might see pop up as just UB. It's one of the harder types of problems to debug. Again, warning, you should avoid this at all costs, because it will take you probably days to solve this issue, especially if it's like it works on my machine, doesn't work on yours. So this is one of the reasons why programming is hard, and why, despite lots of smart people working on Mac OS and Windows, you still have bugs come up, mainly because of things like this. So you might ask, what happens if we mix types? So the operators addition, subtraction, multiplication, division, mod are all binary operators. The rules in C are that if both of the operands are an int, the result is an int. And for mod, both operands must be int, so it doesn't make sense to do a mod with doubles. The rule is if at least one of the operands is a double, the other gets converted to a double if it is not one already. So, for example, here, let's see an example first. So, in this case, I have x 3 divide 2, where 3, if I write something without a decimal in it, it means it's an integer, and x, the resulting type, is also an integer. So everything here is all integers. For double y, y is a double, and if I just write the number with 0.0, that means it is a double. It's just a double number. If I don't have a decimal, it by default is an integer. So this division is with 2 doubles. So quick quiz. What is the line going to print with x? So what's going to be the result of 3 divided by 2? Yeah, 1, right? So the answer in real math is 1.5, but because those are all integers, it gets truncated. So 3 divided 2 is actually going to be the integer 1. What about 3.0 divide 2? What's the answer of that? Yeah, 1.5, right? So if I go ahead and do this, this is called division. I'll see that x is equal to 1, y is equal to 1.5. So what about knowing the rules I just said before? What about if I change this 3.0 to just a 3? What will the result of y be now? Yeah. Yeah, still 1.5, right? So the rule is if at least one of the, so it's 3 divided by 2.0. This is an int, this is a double. So the rule is if at least one of them is a double, the other gets converted to a double. So 3 will get converted to a double, so it'll be like I just typed 3.0. So this whole thing is going to result in double divide double, so that will be 1.5. All right, harder question. What if I do something like this? Will I get, let's see, hands up for still 1.5. Got a few 1.5ers. What about 1.0? Few more for 1.0. All right, well, let's see what happens. So we can compile it, we can run it, and it is 1.0. Why? Well, what's going to happen, and what my compiler is trying to tell me about, is it says the result of an integer division is used in a floating point context, possible loss of precision. So what's actually happening here is, well, this is 3 divide 2. Both arguments are an integer, so it's going to do integer division. So the result is going to be just 1, like before. And because y is a double, it's just going to convert that resulting integer to a double. So it's just going to become like 1.0. So in this case, it's going to just do that. I'm going to get the answer 1.0, which might not be what we expect. So some things I can do to kind of work around this is, well, when I convert an int to a double, basically we add like 0.0. So if I write something like, I don't know, 2.5 plus 2, and then write 2 with an int, well, that just gets converted to 2.0, which is a double. So in this case, the result of adding these two things, so again, this is a double plus an int. This 2int gets converted to a double because at least one of the arguments is a double. So my result of this is going to be 4.5. So this automatic type conversion is called implicit type conversion. So changing an int to a double. Implicit means I didn't request it. It means C did it for me. So if I want to do explicit type conversion, what I could do is explicitly do it, and conversion from a double to an int just truncates. So I can do explicit type conversion with something called a typecast. So a typecast is a unary operator. Unary operator means it just takes one argument, just like, I don't know, an exponent or something like that. And this is the form it takes. So it has parentheses and then the name of a type. So in our case, an int or a double for the most part. We also know what a char is and a bool, but typically you don't use it for that. You can, weird things might happen. And then the value we want to convert to that type. So it has higher precedence than the binary operators, and it is right associative. So if we have multiple typecasts all in a row, it will do them from right to left order. So some examples, if I write parentheses int and then 2.9, well, that's going to get truncated just to 2. It's just going to lop off the decimal place to convert it to an integer. Everyone okay with that? Just like for division. Then if I write something like double 5 divide 2, this will get computed as if I put in explicit brackets in it. This typecast is done first. So first thing it's going to do is convert the integer 5 to a double. So after the first step of converting the integer 5 to a double, it would be like I actually type 5.0 divide 2 in which case that's doing a division with a double and an int. So it's going to implicitly convert this 2 to a double. So it's going to be 5.0 divided by 2.0, which is going to give us the result 2.5. If instead I do something like this, I do something strange like brackets double, brackets int, 1.9, how that's going to get computed is everything happens in right to left order. So it will do this int converting 2.9 to an int first. So after the first step, it will convert 2.9 to an int, which will just chop off the decimal place. So it will just give a 2, and then it will convert that 2 to a double, which is just adding a 0.0 on at the end. Yeah?
So essentially, if you're going to floor a number, you just
Yeah, so like this thing I did of converting a double to an int like that, that's basically a floor operator, right? So if I wanted to do a floor, I could basically do it like that. Yeah, and also this truncation, probably a good way of figuring out how many free donuts you'll also get in lab 1, 2, right? So if I have 5 donuts or 4 donuts, like if I have 4 donuts, I should get 1 free one. If I have 5, I should get 1 free one. You can probably figure out how to do that using truncating division without having to do anything more complicated than that. All right, so another thing that gets a bit weird is assignment that we discussed before is technically also an operator. So it's a binary operator that's right associative. So again, you will do things in right to left order, and it's the lowest precedence we've seen so far. So the result of an assignment operator is the value assigned. So if I write x equals 3, technically it's an expression, and the result of this expression is whatever got assigned. So the result of this is 3. So usually you shouldn't use the result of an assignment. It's usually a bad thing, but the reason they put this into the language, so you can write something like this. Again, I do not recommend this, but you can technically write something like y. If you have a variable x and y, you can technically write y equals x equals 3. And how that gets computed, again, we do the grouping for the assignment operator as right associative. So it would do x equals 3 first. So after the first step, it updates the value of x to be equal to 3, and the result of this returns 3. So the next thing my computer will calculate is y equals 3, then it will assign 3 to y. So I can assign 2 things on the same line. Again, especially if you are just starting, I would highly recommend just doing it on 2 separate lines, because this can get confusing, especially as your programs get bigger. But be warned, some people might try to do this. So there's also a shorthand. So you might find yourself doing something like x equals x times 2, like I just want to double a number. So I'm just updating the current value, multiplying it by 2, and reassigning it to that same variable name. So instead of this, C programmers are lazy, and we have a shorthand for this. So instead of this, I can technically write the multiplication equals 2. And what that will do is exactly the same thing. So basically, it will just take this x and put it on the left-hand side and multiply that by whatever is on the right-hand side of the equal, and do the exact same thing as the line above. So applies the operation to the value on the left of the assignment, reassigns it with the result. So these 2 lines are exactly equivalent. This one is just a bit shorter. So there's shorthands for all types of binary operators. So you could do plus equal, minus equal, multiply equal, divide equal, mod equal, if you would really want to. So you might see that come up in your programs as well. There's also other shorthands. So later in the course, this will become more of a thing, but there's more shorthands. Typically in computers, adding and subtracting by 1 is exceedingly common. So I could do plus equal 1 or something like that. In computing, we have even special names for this. So adding 1 to a variable is just called incrementing it, so increasing it by 1. Subtracting 1 from a variable is called decrementing, or decreasing it by 1. In C, there are operators specifically for this. So it's a unary operator, and I can do plus plus and minus minus. So there's 2 versions, and the operator can either come before the variable name, which is called prefix, or after the variable, which is called postfix, and they behave slightly differently. So they're supposed to update that value by 1. The difference between the two is the result of the operation. Typically, again, you shouldn't use the result of like a plus plus operation in your program. Some people do because it will save like a line of code. So I'm going to show you it just in case. So it's good to know this, but you typically shouldn't use this how I'm going to show you. So initially assume I have the variable x equal to 0. If I do plus plus x, it will actually add 1 to x, and the result of this expression, so this is technically an expression, that plus plus x is the updated value. So the result of plus plus x is the value 1. So it was originally 0. If I add 1 to it, it becomes 1. So its new value is 1. So the result of plus plus x is 1. If I do the postfix operation, which means the plus plus comes after the variable name, if I do x plus plus, that means I add 1 to x like before, but the result of this expression is technically the original value. So in this case, the result of x plus plus is 0, not 1, even though the updated value of x is still 1 after this expression anyways. So it's a bit weird. Good to know this rule if someone writes it in their program, but if they write it somewhere where it shouldn't be, typically if you just do plus plus x or x plus plus, it should be the only thing on that line, so it should just end with a semicolon. That should be the only thing that line does. So in both cases, x gets reassigned that value to that value of 1. And for reasons we won't quite go into in this course, you should always prefer the prefix version, so this plus plus x, over the postfix version, unless necessary and you actually need the old value of x as part of the expression. Typically, you will never need it, so all you need to remember is if you need to increment something, do the prefix version of it. You'll learn why this is a thing. Basically, there is some cases where this kind of needs to save the old value, and in some cases, it can cause performance issues where your computer, because it has to remember that, runs a lot slower. So that's one way to try and remember which one you should use. Okay, a few other operators we have is one's called size of, and that takes as an argument a type and tells you the number of bytes used to store that type. So works on variables and types, and again the result is the number of bytes used as an integer. So you can use this to verify the number of bytes used for some types. So if I do size of int, it returns, or it results in the value 4, because an integer is 4 bytes, as we discussed before. If I do size of double, the result is an 8. If I do size of char, the result is 1 byte. And if I do size of bool, the result is also 1, because even though a bool technically could be only represented as a single bit, computers and memory, the smallest unit is a byte, so it has to consume a single byte. So if I declare a variable called double x, I could also do size of x, and it will go ahead and give me the result of a 8, because x is a double and its size is 8 bytes. All right, so here is a summary. Instead of going to that c++.com page, you can refer to this slide. So here is a summary of all the precedence rules for all the operators we went over today. So lower precedence is lower on the slide, higher precedence, or more important, is higher on the slide. So the absolute highest precedence is the postfix plus plus and minus minus, which just increment or decrement a variable, and its associativity is left to right. So if there's multiple in a row, it groups it from the left to the right. So this level is all the unary operators that only take one argument. So I have the prefix plus plus minus minus, the typecast, so changing the type of a value or variable to a different type. And then what we saw before, the ampersand, that's address of, to get the address of a variable. So that's also an operator. And also size of is another operator. So the other ones we have are multiplication, division, and modulo. Those are higher precedence than addition and subtraction. And like in math, the associativity is left to right. And then there's all the assignments. So just the assignment operator by itself or all the shorthands. They are the lowest precedence and their associativity is right to left. But again, I recommend just putting one assignment per line on C. So other things we can do to our code to make it a bit more readable, which I guess is one of the things they're looking for in Lab 1 as well, is you can add comments to your code. So a comment is a note for you and others like the TAs to read. The compiler ignores them. Typically, it's a good idea to write comments to explain why you are doing something, because as you program, you're going to write something, it's going to work, kind of. You're going to have to do something weird to fix it, maybe. And you might have to come back to this code in a year, and you will forget why you have done something. So that's what comments are good for, kind of a note to your future self. You can either be nice to your future self, leave yourself a descriptive comment so you don't have to figure out why you did what you did again, or you could be a jerk to your future self and just write nothing, and then you'll have to figure it all out again. So be nice to your future self. So how comments work is any text between a slash star and a star slash to end it is considered a comment. If I don't want to do that, that will work for multiple lines. I can also use just slash slash, and then everything after that is ignored until a new line character. So if I wanted to comment a hello world program, I could add a comment to this std, this include std.lib, and say why I added this. So I just could say I need this because I need it for this exit success name. And then I could describe what happens in main. So I said the program will start here and it will finish when it hits return. And then the rest of it is kind of self-explanatory. It prints out or outputs hello world and returns exit success, which means it is successful. All right, so some practice we can do. Let's see. So we did that. All right, so here is where it might get surprising. If I ask any sane, rational person what 1 divided by 2 plus 1 divided 2 is, you would hopefully say 1, right? What's a half plus a half? It's equal to 1. So if I run this, what is C going to say the answer of a half plus a half is? 0, right? Which might be our first surprising kind of thing we need to fix and debug. So everyone agree that this is 0. So first surprising thing, let's go ahead and run it and verify that it is indeed 0. So if I run it, the result is 0, which again, knowing math, and again, this should be some evidence as why computers are not as smart as you think they are, because that should clearly be 1, right? But C says 0. And now, after this lecture, you should be able to explain why the hell C is giving me such rubbish. Well, again, if we do all of our precedence rules, division will happen before addition. So how this will actually get evaluated is first I will do what's in, if I add the brackets, I will do the division first. So this is 1 divided by 2. Both 1 and 2 are integers. So it will do integer division here. So the proper result should be 0.5, but because it is integer division in C, it's truncated, so the answer is just 0. And then I do this other division, 1 divide 2. Well, again, both integers. The proper result should be 0.5, but gets truncated. So this is 0. And then C will do 0 plus 0, which will, of course, be 0. So my final answer will be 0. So everyone understand why that is. All right. Any other questions about anything we went through today? Yeah?
So with the commenting, so
Yeah.
for the lab, does the auto grader care if you comment it or not, or just TA? Do I have to push my code again with my commenting, and it's not really wait for it?
So the question is, do comments matter for the autograder? The answer to that is no, but I believe the TAs are going to look at your comment. I believe the coordinator gave some guidelines. You should have a comment for approximately every 5 lines of code or something, which means for lab 1, probably like 1 comment or something like that. And you should add that and push it because the TAs are going to look at that, I believe, next week in your practical sessions. All right. Any other questions, comments, concerns? So, to summarize, arithmetic, kind of weird in C. Just remember these got yous that if they're integers, it will do truncating division, and you should think about how to leverage truncating because in some cases it's useful, like in figuring out how many free donuts one should get